So I assume that okay, you are a layman for data warehousing and informatica, and I will be explaining as is. Okay, so just please bear with me. Okay, coming to data warehouse. Okay, before going to the data warehouse, okay, just we'll think about two things. Okay, one is data and data warehouse. So why do we need data and why do we need data warehouse? What exactly is data warehouse? All these things. Okay, so when we are talking about any data warehouse, it is a collection of data, okay, that is designed to support decision making. Now you will get a doubt that why do we need to store the data and how it is going to support the decision making. So we will think in a normal business perspective. Just think that you are running a business, just a small shop, okay, kind of thing. So how are you going to run your business? You will be able to run your business effectively or efficiently when you understand your business thoroughly. So if you know like which products are moving good or which products are not moving, and if you know that which products are giving you high margin rate kind of thing, you can still have good good move in the market and all. So if you understand your business in that perspective, okay, whether the goods are selling or not, whether you are getting enough margin or not, all these things, okay, that will help you to make the decisions. Okay, similarly, if you think just if you're having a single shop, you can just analyze your business, okay, on your own. But just imagine, okay, if you're having a retail business with 1,000 branches, okay, or more than that, or 200 branches or 300 branches, that kind of scale, okay, in that situation or scenario, you will not be able to understand your business on yourself, right? So you need to depend on the data. So for that you need to collect it firstly, right? So you need to collect it. Is a data warehouse. Okay, your data warehouse is going to help you in that manner. Here you are going to store your business data, and you are going to analyze that data to understand your business, which will help you to take the decisions. Okay, now we'll go to some definitions, okay, given by some data warehouse gurus. Okay, and Bill Inman is one of the popular data warehousing guru. Okay, so he has given a definition. A data warehouse is a subject-oriented, integrated, time-variant, non-volatile collection of data in support of management's decision-making process. Okay, he has actually given some certain properties to the data warehouse. Okay, when you're talking about a data warehouse, it will have certain properties, right? So Bill Inman has given some properties to the data warehouse. We will see those things, okay, in detail in the next slides. So for now you understood, right? Like a data warehouse is a collection of data designed to support the decision making steps. Now you understand like why we need data and how it is going to help you in the decision making. Okay, so this is what we are actually discussing about, right? Like now we are having two things here. One is OLTP and another one is OLAP. What is OLTP and what is OLAP? We'll discuss that thing. Okay. Firstly, OLTP. It is an online transaction processing system. That means you are going to process the transactions using this system or software, and then you are going to store that information in the on the data warehouse beneath that. Okay. And coming to OLAP, online analytical processing system. Here you are going to analyze the data that is already stored, okay, or already collected using OLTP. So that is the difference between OLTP and OLAP. So when you're talking about OLTP, you're actually doing some transactions using OLTP, right? So it is transactional, whereas OLAP it is analysis, used for analysis. So, and when you're talking about type of user who is going to use OLTP, so generally the person who will be building, okay, he will be using the OLTP systems or some DBA to maintain that OLTP systems. Whereas OLAP will be used by the knowledge worker to analyze the data. The person who is going to analyze the data that is stored in your data warehouse will be using the OLAP system. And OLTP is to run the day-to-day operations, to sell the thing or to add the new stock kind of thing into their system. That kind of information you will be using the OLTP. Whereas for OLAP, you will be using for long-term informational system requirements. In the sense, you will be storing the data for historically, like 5 years, 10 years, depending upon your requirement, and you will be analyzing the data over time. That's how you use OLAP. And the same thing continued, okay. And DB design, it is ER based and application oriented. So you will be having an application to run your business, right? So OLTP is completely based upon that application, and that is called ERPs, right? Enterprise Resource Planning kind of thing. So that kind of systems are called OLTPs. And OLAP is star or snowflake based on subject oriented, okay. These things we better discuss in the next slides, but for now just think that this is about database designing. That means how you are going to store the data in the data warehouse. So this is called star and snowflake. We will discuss in detail in the coming slides. Okay, axis, read or write, and mostly read. So when you are using your OLTP system, here you are using two things, right? One is to do the transactions, and those transactions will be updated in the database, right? That means you are writing the data into database, right? Secondly, reading. So for operational purpose, you might need some certain reports in the sense like what is the current stock, okay, for which products you are running out of stock and all. If you want to understand such kind of business operational situations, you might be using certain reports, and for that purpose, you will be reading the data from the OLTP. Okay, and coming to OLAP, here more than writing, here it's more about reading the data. That means whatever data that you stored over the years, you will be analyzing it. You will be understanding the trends, okay, and the data size. OLTP, it will be of small size because you will be using only current data. Once the data is old, okay, or stale, you will be storing the data in the database. Whereas the OLAP, you are storing the data historically over the years, so it will be huge compared to the OLTP. Coming to the data warehousing life cycle, just like any business process or business function, you will be having a life cycle for the data warehousing as well. Okay, just we'll go through it each and every phase now. Phase one, business requirements collection. Okay, see, when you want to build a system, either it is a data warehouse or ERP or whatever it is, you need to understand the business requirements, right? So even in the data warehousing as also, we will try to sit with the business users or any technical persons, okay, who has the business good understanding on the business, okay, and we will try to understand what exactly they are looking for in their data warehouse system, okay, like what kind of data they will be interested to look at, whether they will be interested to look at the aggregate data or some other kind of data. And within the data, like what kind of data, is it HR data, is it marketing data, sales data, what kind of data they will be interested to look at, and at what level, okay. So all this information will be collected in the business requirements collection phase. Once you are done with that, okay, uh, once you are thoroughly understood the requirements, then you will step into the data modeling. What is this data modeling again? It is another phase, okay, where you will be designing the structures or tables in the relational database. So here you will design the tables, okay, depending upon the business requirements, and you will define the relationships between the tables, okay. Next is ETL development. Once you are done with the data modeling or your database designing, next step is creating the code to move the data from OLTP system to OLAP system. Do you remember that, like, we are talking about OLTP system where we'll be storing only current data, or okay, which is very much required for the operational purpose. Once it becomes stale, okay, or once it is irrelevant for the operational, we'll be moving the data to some other place, right? Whereas in data warehouse, we need historical data. So we will be moving the data from OLTP to OLAP, okay? So for that purpose, we need a code, right? So that code will be developed in the phase 3. Okay, but once you are done with the developing that code, we should make sure that that code is okay, following the standards and business requirements, right? For that purpose, we have a separate phase for ETL testing. Okay, this is to make sure that whatever ETL code that you have developed, okay, is fulfilling the business requirements, okay, to reduce the errors or all those things. And then report development. Once the data is available in the data warehouse, you can start building the reports, okay, which will help you to analyze the data that is present in the data warehouse, and then deployment and maintenance. This is about, see, once you are done with the development and testing phase, you will be moving that code to production, which will be used, okay, by the business users, and that need to be maintained, right, without affecting their business. So that is the last phase. Now, see, do you guys remember that we were talking about few properties, okay, uh, of a data warehouse that was given by Bill Inman. Please remember that these properties are actually given at the time of beginning of the data warehousing era. They may be relevant now or they may not be relevant, okay. But these are the properties that were given by Bill Inman for the data warehouse, and they were actually at the time of maybe 20 or 30 years back when the data warehousing was in the beginning stage, okay. So I'm going into details of data warehousing now. Subject oriented. So what do you mean by subject oriented? So when a business user is looking at the data, uh, will he able to look at the data at once, entire data at once? No, right? He might be interested to look at, okay, any particular subject, be it sales data. Within sales data, again, he might be, okay, interested at one particular region kind of thing and all. So he's actually interested to look at one particular data. So when we're talking about subject oriented, it's about business user preference. Okay, what kind of data he is interested to look at, what kind of business you want to analyze. So we are actually talking about that information. Okay, next is integrated. Now we might have a business scenario where our business is run using multiple applications. Say if you go to any current banking system in India, they might be using multiple applications, one for the banking things and other for the other additional services that they are offering. Okay, so in such cases, okay, you need to collect the information from multiple sources, right? So that is a term called integrated. These two terms are still relevant. Okay, and so here when you are talking about multiple systems, you will be reading data from the multiple systems and load and integrate them into the data warehouse. So that's what we are talking about. Next is time variant. See, this is one of the important aspect of data warehouse. When you are analyzing the data in the data warehouse, that is actually against the time series, right? So you are having historical data. So you might be interested to understand data, how it is actually improving over the time, how it is actually, and you might be interested like within the year itself, okay, how it is actually impacting in different seasons or how it is actually improving over time and all. So data against the time series. That's how we understand our business. That's what it is talking about. Next, non-volatile. Okay, in general, okay, when the data warehousing actually started, okay, they were actually talking about non-volatile. That means like once the data is actually loaded into the data warehouse, that is not going to change. Okay, it is going to be permanent. But nowadays, okay, with the current business requirements and all, people may not be interested to look at the complete historical data. But so in such cases, it may be volatile. Okay, that means like we might put some data kind of thing and all. So, but still like non-volatile in the sense like once the data stored in the data warehouse will not change over time. Now coming back to data warehouse design. So when we're actually talking about different phases in the data warehouse, okay, we're actually talking about data modeling, right? So now when we think about it, okay, we need to design a data warehouse, like you need to create some structures and you need to define some relationships, right? So when you are going to do that, we need to understand certain principles. They are called star schema, snowflake schema, and galaxy schema. Okay, they are actually different data warehouse design techniques. Okay, so we'll be going into each of them in detail now. Star schema. So it's a database design in which we'll be having a fact tables and dimension tables. Okay, like we'll be having a centrally located fact table and surrounded dimension table. Since it looks like a star schema, a star, right? It is looking like a star. So we call it a star schema. Snowflake. It is also like more or less same, okay, except that in Snowflake schema, certain dimensions will be denormalized, meaning they might be split into multiple tables, okay, resulting in more complex graph forms. Okay, see if you look at the star schema and if you look at Snowflake schema, what is the difference that you see? There is some additional tables for store and product dimensions. They're actually denormalized and split into multiple tables, which is okay, which now it looks like a graph kind of thing, right? So that's the difference. So when you are having in a star schema, it's a simple form. Okay, you will be having a fact table and surrounded the dimension tables. Snowflake schema also looks similar, but you'll be having additional, denormalized tables here. Okay, which makes it more complex. And then comes galaxy schema. This is more sophisticated thing. Okay, here if you we also call this as fact constellation schema. And if you look at the image, okay, you can see here that there are multiple fact tables and certain dimensions are shared across the fact tables kind of thing, right? So this is actually combination of star schemas and snowflake schemas or vice versa. Okay, it can be either way around. Data cleansing. And when we're actually talking about different phases of the ETL, data warehousing, we're actually talking about ETL development, right? So when we're actually loading data from OLTP system to data warehouse, are we going to load the complete data? Does it make sense if you are going to load each and every data that is stored in the OLTP? So say for example, if you go to a retail store, you might, if you purchase something, okay, your bill might have some irrelevant things like time of purchase. So when you are going to analyze the data, does it make any sense to analyze the data based upon the time of purchase and all? May not in most of the cases. Okay, so when you're going to load the data from OLTP system to the OLAP system, you need to cleanse the data. You need to capture the data which is required for the business user and omit the data which is not required for him. So that is called cleaning. Okay? So you are going to load only that is required for the business user.
Hello.
So that is called cleansing. So we are actually removing the unnecessary things here.
Hello.
Uh,
Hello.
Gaurav, do I
Yes, sir.
need to continue or can I?
No, that was completely fine.
Fine.
I guess it was completely fine, sir. I'll just have a discussion with my senior as well, and I'll confirm it by
Fine,
today
Gaurav. Take your
afternoon
time.
itself.
Let me
Okay.
know by. Fine, Gaurav. Take your time.
Okay.
No issue.
Okay. Thank you, sir.
Thank you.